Alright, welcome. This video is just going to be reviewing a bunch of stuff from chapter 13. So as always, I would encourage you to have out a notebook, pencil, calculator, and try the questions with me instead of just passively watching the video. Okay, so the first one is going to be, I think one of the hardest things is to find the exact values. So what I mean by that is like you can find these values on your calculator by just typing them in. Okay, but we want to find the exact values. And I guess for negative 60 would be okay because it looks like that's just going to be 1/2. But we want an exact value here, not a crazy decimal. Okay, so the way we're going to do this is draw it in this like unit circle where the radius is 1. Make this as big as I can here. And then use 30, 60, 90 or 45, 45, 90 information. So I'm going to start by drawing a negative 60 angle. So we're going to have the positive x-axis. That's one side of the angle, and then I'm going to go down 60 so that it's going to look like that. Okay, and there is my negative 60 degree angle. Though for our purposes, I don't know, we might end up thinking of it as positive because a negative angle is kind of a weird idea. But let's draw in our right triangle from here. So now I'm going to take and I'm going to draw back to the x-axis. You always draw back to x and then put this here. Okay, and now I just want to label my sides with the 30, 60, 90 info with the radius being 1 or the hypotenuse being 1. Because in this unit circle, the radius is always 1. Okay, so that means this short side would be half of the hypotenuse, and then the long side is square root of 3 over 2. All right, and so those you just kind of gotta know. I can't remember, we'd give them to you probably on the test for this, but anyways, you gotta know that triangle in full. And then now I'm just going to use these sides to do my cos and tan, right? With this being my reference angle in here. Okay, so let's see, cos for negative 60 at this point, sorry for the bell there, would be adjacent 1/2 over hypotenuse. So I'm going to do adjacent 1/2 over hypotenuse 1, and that just comes out to be 1/2. Right? And I probably should have specified that this one's going to be negative because I went down. So over here I went right, so this is positive, but that should actually be negative square root 3 over 2. Right? And we'll see, I think that'll matter when I do tan. So when you do tan here for negative 60, we're going to look at our triangle again, and we're going to do op and adjacent. So here's op across from the angle, and there's adjacent. So op is negative square root of 3 over 2, and adjacent 1/2. And now I just got to clean that up. So I'm going to do this as a division problem. So this fraction bar right here is division. So I'm going to take this thing, divide by that one, and then I'm going to multiply by the reciprocal. So times 2 over 1. Sorry for the bad square root of 3 there. Maybe I can fix that a little bit. Okay, and now these are going to cancel, one on top and bottom, so we end up with negative square root of 3 over 1. So the tan of negative 60 is that right there, right? And that should match what we got on our calculator, right? If we do negative square root 3, that matches the crazy decimal we got there, all right? So looks like we did it right. And again, on the test, we want the exact value, not the crazy looking decimal. Okay. All right, next up, coterminal angles. Remember, angles in standard position look like this. They have one side of the angle along the positive x-axis, and then if it's a positive angle, it goes up, and if it's negative, it goes down. So take a look at this picture and see if you can figure out some angle degrees that would be coterminal and at the same spot as 45 degrees. Pause the video. Okay, and so you can even see it visually that if I went negative 315 degrees, that would be coterminal. All right, and so kind of the way you figure it out is you just go, like if I'm here and I went around this way, that would be like negative 360 degrees. So from the 45 position, if I went negative 360 degrees, I'd be at negative 315. So kind of the thing you do is you add or subtract 360s. So same thing if I was in the positive direction. If I was at 45 and then I went another 360 positive, then I would be back where I started. So if you take 45 plus 360, you'll get another coterminal angle of 405, right? And you can just keep doing this as much as you want to get as many coterminal angles as you need. That would be 765. So some of the ones, if I listed them order, would be negative 315, the 45, and then what was it, 405 and 765. And all of these are 360 degrees apart. So you just add or subtract 360, and that gets you as many coterminal angles as you need. Okay, so I think this is something that students get confused on, is they think like the two coterminal angles would add up to 360, but that's actually not right. So we got Sally here who says 90 and 270 are coterminal. Explain why that's not correct. Explain or show. So pause the video, give it a shot. All right, so for the best way I think to explain it to me is to draw a picture. So a 90-degree angle would be that, positive 90. All right, and then a positive 720, right, is not coterminal because it doesn't end up at the same spot. So if we draw 720, I go up 90, 180, 270. Okay, so sorry I didn't draw that super well there, but that would be a positive 270, and you can see that they're not coterminal and they don't end up at the same spot. And then I would say to Sally, probably what you're mixing up is like 90 and negative 270 are coterminal, right? But they don't add up to 180. I mean, I can kind of see where they don't add up to 360. I kind of see where she gets that idea, but they actually would add up to negative 180 here. But those would be coterminal because if we have the 90 and then we have negative 270, we go this way, and then we're at 270 there, so that would be negative 270, and that would be coterminal with 90. But positive 90, positive 270 are not coterminal. Hope that made sense. Okay, so there'll definitely be a question about converting. So if you forget, the key ratio on this one is 180 degrees is about 3 radians. It's about pi radians, right? So use that to convert here. Okay, so I'm going to do a proportion and say we have 5 pi over 6 radians, and we want to know how many degrees that is, so we're going to put x. And there are many ways to solve these, but the way I generally going to do them is cross products. So we're going to take pi times x and set that equal to 180 times that fraction. Okay, and so when I multiply these fractions, I'm just going to multiply the numerators and multiply the denominators. So I'm going to make that denominator 1. And actually, before I would multiply, I'd actually reduce. So the 180 and 6, I think it's easier to reduce ahead of time. So 180, you can divide that by 6 actually, and you'll get 3 and 1. Divide both by 6. And then what we get on, maybe I should just do it in 2 sides. So what this side would clean up to be then 30 times 5 pi, be 150 pi, and then our denominator is just 1, which is great. So now we have pi x equals 150 times pi, and you can divide both sides by pi and they essentially cancel out. So we get 150 degrees. So 5/6 pi radians is 150 degrees. And you'll always use this setup to convert. Okay, so I got another question here that I thought would just help us explore a little bit more of this idea of radians. So hopefully help cement your understanding. So I invented a new way to measure angles, and 1 Westpital is equal to 30 degrees. So I have a couple questions. Is 1 Westpital more or less than 1 radian? And then convert 4 Westpitals to radians. So pause the video and see if you can make some sense of these before watching the solutions. Okay, so in general, like 1 radian is about 60 degrees. Okay, and the reason I remember that is I just think 180 degrees is pi radians, but I just think of pi as like about 3. So 180 degrees is about 3 radians, and so if we reduce that 1 radian if you divide by 3, 1 radian is about 60 degrees. Okay, so 1 Westpital would be less. Like 1 Westpital would be less than a radian. Because it's 30 degrees, right? And 30 degrees less than 60 degrees. All right, so if I had to convert Westpitals to radians, I would just take 4 Westpitals times 30 degrees each. So that would be 120 degrees. And then I would convert that to radians. So I know that it's 180 degrees for pi radians. So I would put 120 degrees here and x radians and then just convert. So doing our cross products, I have 180 times x equals 120 times pi. And then solve for x, so I'm going to divide by 180. And so my answer is this thing on the left, but instead of doing decimals, I'm just going to reduce the fraction. So you can chop off the zeros, and then 12 and 18 are both divisible by 6. So I think we get 2/3 pi radians. So 4 Westpitals is equivalent to 2/3 pi radians. Okay, so draw an angle in standard position. See if you remember how to draw negative 340 degrees. Pause the video. So standard position, we always have the positive x, and then if it's a negative angle, we go down, and we just got to go 340 degrees. So, you know, this is 90, 180, 270, and then from 270, if we do the difference here, I think we got to go 70 more. So I'm going to go 70 more here approximately, and then draw in that. So that's negative 340. I guess another way is you could have went 20 up and then drawn that. But when you draw it, you should draw with the arrow here, because there is really 2 angles here, right? That's positive 20. That'd be coterminal. But the angle we were trying to draw was negative 340. So we want to go this way, go down, get a little Pac-Man shape. Okay, next up, we're going to do sine, cos, tan stuff. And if you forget, remember, sine, cos, and tan, you have like an angle measure here. And then for each angle, there's an associated ratio, right? So if you do like sine 30, I think that's 1/2. And sine of 30, so like basically it's saying the op to hypotenuse ratio for a 30-degree angle is 1:2. The hypotenuse is double the opposite side, right? So that's how it works, is you give it an angle and it gives you a ratio. And remember, the inverse goes reverse. It starts with the ratio and gives you the angle. So if you do like inverse sine of 1/2, that gives you the the angle associated with that ratio. All right, so first one here is to find h using sine, cos, tan stuff. Pause the video, give it a shot. So first thing is, I got to figure out, is it a sine, cos, tan question? So this side, from the angles perspective, this one is op, and this one is hypotenuse. So op hypotenuse is sine. So the setup is sine, and then the angle measure goes here, which we happen to know is 51 degrees, equals the ratio of op to hypotenuse. Okay, and so we want to do find the ratio for 51. What's the sine ratio? So just type it in your calculator. Type sine 51. Okay, and if you don't get the same ratio as me, check your mode, right? You got to make sure you're in degree mode, not radian. Okay, so I'm just going to call that 0.78 to make it simple. So it's 0.78 to 1. That's the known ratio if the angle is 51 between op and hypotenuse. And so set that equal to our ratio of 10/8, and then solve with cross product. So we have 0.78 times h equals 1 times 10. And then divide by 0.78. And our hypotenuse should be something bigger than 10. All right, so we got something that makes sense, 12.82. Again, visually, you can see that this side is 10. It makes sense that this one's about 12.82. All right, it definitely should be bigger than 10. If we didn't get something bigger than 10, we should go back and check our work. All right, thanks for watching.